It's third hour, Mr. Schmitz.
Yeah, but I don't know which day third hour is.
It's
Thursday.
Go one.
Okay. So on Friday we mentioned that we've got this concept called enthalpy, the flow of heat. Things like the flow from hot to cold. If it's flowing from hot to cold, you have an exothermic reaction. Delta H will be negative. That's a favorable thing. To go the other way, delta H being positive, that's an endothermic reaction. That is not favorable. Okay? We don't want to have to put energy in. We like to get energy out. And then on Thursday and Friday, we said, well, there's this other force in the universe called entropy. And that things like to go from order to disorder, that is favorable. Going from disorder to order, that is not favorable. Now, the numbers are opposites from enthalpy S to entropy. If you have a positive delta S, that's good. But if you have a positive delta H, that's not good. And same thing with a negative.
Is S, entropy?
S is entropy, a measure of disorder. And enthalpy is heat, a measure of the heat in the system. So then, what's up, Louis? On Friday, we wrote this equation on the board. Barium oxide plus sulfite going to barium sulfate. And we calculated the delta S of this reaction. And we said if delta S is positive, that's favorable. If it's negative, it's not favorable. And here are a few examples that I want to go through with you before we go back to that example.
Mr. Strauss, whenever I go to order to disorder, it's not favorable. What the heck, man?
Okay, so let's say we've got our hydrogen gas reacting with oxygen gas to form liquid water.
Bless you.
Is this reaction, is this going from disorder to order? Or is it going from order to disorder? What do you think? What do you think, King?
Disorder to order.
Why do you think it's going from disorder to order?
It's from like 2 to 1.
So we've got how many moles on this side?
2.
Well, 2 moles of H.
Oh, 3.
A total of 3 moles going to 2 moles. So anytime you have more moles on the left side than on the right side, you're going towards disorder. No, I said that wrong. Order. Anytime you have more moles on the left side than on the right, you're going towards order. Another thing we got here, Malia, is on this side we have all gases. Right? Gases are very disorganized. The molecules are flying all over the place. A liquid, we're starting to put the molecules close together. We're starting to create some patterns. So liquids are much more ordered than gases. So we have 2 things going on here. 1, we're making liquid, and 2, we're combining our moles to make fewer moles. So this is very much going from disorder to order. And so what's the value of delta S going to be, Caitlin? Positive or negative?
Positive.
Positive.
No, negative.
No, negative, sorry. If we're going from disorder to order, it will be negative. How about the next one, Noah? Is delta S going to be positive or negative?
It's going to be positive.
So are we going from disorder to order or order to disorder?
We're going from disorder to order.
Okay? Disorder, because a big pile of bricks is a lot of disorder. Something's wrong there.
You spelled that out.
There's no R. Everything in R.
Disorder.
Disorder, there we go. And we're going towards order, so that means our delta S will be positive.
Negative.
Negative.
Ah, jeez.
Mr. Strauss, which one is heavier, a pound of bricks or a pound of feathers?
They're the same. You can't get a science teacher on that. You can go get an English teacher on that one.
Oh, hey, Mr. Rose, I have a
Yep.
question. So if you're in space, do you know which way's up and down?
Is there an up and down?
There is no up and down in
Because
space.
the thing, you know, the thing in your head, what it's called, but.
Oh, you're in equilibrium? No, you don't.
If, whatever thing.
It's
you don't-
kind of like being like underwater. If you get turned around underwater, you don't feel the gravity as much. You don't know what's up or what's down.
Does it mess up your hearing?
In fact, that's what happens sometimes with divers. When they go real deep, if they get disorientated, they may think they're going to the surface and they're actually heading down deeper.
I didn't know.
So
Aren't they like
why don't they just watch the bubbles go up?
If you're disorientated,
Yeah, the pressure gets.
it gets higher. But there are some people that, it gets colder, you start to go,
Crazy?
Loopy. you know.
They go to disorder.
Okay, how about the next one here, Travis? We got sodium chloride, solid, becoming aqueous sodium ions and aqueous chloride ions. What's delta S going to be?
Positive.
Because we are going from
Order to disorder.
order to disorder.
There you go, Mr. Strauss.
Finally, I got it right. Now, how about the next one? We're not dealing with specific elements. We're saying I've got element A, B, C, and D. So I got 4 elements or compounds, and I'm combining them down into 2.
Negative delta S.
What's it going to be, Malia?
Delta S equals negative
And why?
because you're going from a higher amount to a lower.
So here we got 4 moles, combining it down into 2 moles.
Well, how do we know that if the 2 moles are the ones in the common state or whatever?
Well, it doesn't say, so we don't know, but you do know you've got 4 moles on this side, and you do know that you've got 2 on that side.
Okay.
But you don't know what state they're in.
But wait a second, don't you have to balance stuff? So like how would you
Well, we don't know how to balance it because we don't know what these things are.
well like
So you can only look at the moles. For this one.
but
Like if we had something up here, we'd have to balance, but this, we don't, that's all 1, 1, 1, 1, 1, 1, 1. We assume the reaction is balanced.
so the first one like it's not balanced, is
Yeah,
it?
it is.
Where's the oh yeah it is. Okay.
Now what if I did this? What if I said that, okay, I take 2 A's, 1 B, 2 C's, 1 D, and I get out 5 E's and 4 F's. Now what happens to the problem?
Positive.
How many moles do I have on this side, Binger? 6. And how many moles do I have on this side? 9. So now I would be going from, well, I'd still be going from disordered order. No, just kidding. Now I'd be going from order to disorder because I've got
This is delta S.
fewer things breaking apart into
It's like 2 mistakes.
more things. Now what happens if you have the same amount on each side though? Like here I've got 1 mole of ethine, 3 moles of oxygen, so I have 4 on this side and I have 4 on that side. Sometimes you may not be able to tell based on just looking at the equation. For this one, you should still be able to tell. Why? Because on this side we have all gases. But on this side, Taylor, we've got a liquid. Okay? Liquids are more ordered. So even though we've got 4 moles on this side and 4 moles on this side, we are still going from disorder to order.
So it's more dense, it's more ordered.
Yes, it's more dense, it's more ordered. Okay? Except for water.
That would be positive.
You should, it's better to say it's more solid. It's, liquids are more ordered than gases, solids are more ordered than liquids.
Why did you say except for water?
Because for water, the solid is less dense than the liquid. But the solid is still more
So does that
ordered.
make delta S negative then?
If
For the very last one.
for the very last one, the delta S would be negative. Now, like I said, sometimes you won't be able to tell by looking at the equation, and then you have to actually go and calculate it out. So last week, Friday, we did calculate the delta S for this reaction. we took the products, 132, and we subtracted the reactants multiplied by their molar coefficients. Just so happens in this problem, they're all 1. And when we did this, we got our delta S to be a negative 11 joules per mole Kelvin. So based on entropy, does this reaction want to occur?
No.
Oh, no.
Is having a negative delta S a good thing? No. So based on entropy, this reaction will not occur. It is unfavorable.